Yeah, welcome back to Engineering Mathematics KAS 303 Introduction of Sets. This is the unit related to discrete mathematics. In this unit, we will cover sets relation function, mathematical induction, pigeonhole principle, and recurrence relation. Today, we will study what is set and what are the classification of sets. Set has a very important role in understanding of discrete mathematics. So let's start. What is set? A set is a well-defined collection of objects. Collection of objects. Well-defined is very important meaning here. Well-defined means which definition is clear. Suppose I am asking you how many students in civil second year in REC Kannauj. You have a fixed number, 63 students are there. So we can make a set of civil second year because we know the number of students that is well defined 63. But if we ask to you, make a set to pupils in a fair or in a market which is highly crowded, then that set will not be defined because many people are entering simultaneously in fair or market and many people are leaving the market. So you cannot count if the market is open, you cannot count the number of persons in the market. In that case, the set will not be defined and it will not be a proper formation of set here. We generally, some people represent the collection word has objects has many meanings. We can use elements also for objects word. We can use member word also. So don't be confused. We can any synonyms for object here. What is the notation of set? We generally take sets in capital letters A, B, C, X, Y, Z, capital letters. And we take elements in small letters like A, B, C, X, Y, Z. This is the notation generally we follow according to the standard books. And for writing the set, we use the curly bracket. Suppose we have A is any set which has three element A, B, C. Here A, B, C are the element, and this curly bracket is making a notation for set here. So if we want to write here what is the belongingness, A is element of set A, so we will write A belongs to set A. This symbol is called belongs to. But if we say is D belongs to A, D is not belonging to A, so D is not belonging to A, not belong. So what is the concept here? We generally represent sets in the capital notation and elements in the small notation. If any element is belonging in any set, then we use this notation. If it is not belonging, we use this notation. How to represent the set? This is our next topic. Methods of representation. There are two methods. First is roster method. I hope you have all studied this in class 9, 10th. And second is set builder form. Or you can roster form. Roster form. So first I am going to study here roster form. It is separated by comma only, separated by comma. This definition I got from NCERT class 10+1. The elements we can write in the set that will be separated by comma. That representation will be roster representation. And if you write, suppose we want to write first example here. set of all natural numbers which divide 42. If we want to write the roster form for this statement, we can write this 42. What are the divisors of 42? 1, 2, 3. You can see that 6 is also dividing 42, 7, 14, 21, 42. Important property is order is immaterial. Order is immaterial. Means we can write like this also. 1, 3, 7, 6, 2, 14, 42, 21. We can write the elements in any order. In the roster form, order is immaterial. Elements are separated by comma, and this is the representation of set here. So overall, this form is called roster form. We have one more example. Suppose we have set of all vowels. So for this statement, we can make another set B. What are the vowels in the ABCD? A, E, I, O, U. So this is the another set which is represented in the roster form. One important remark for the roster form is while writing the set in roster form, an element is not generally repeated. Means if any element is coming twice, thrice, or many times, we write only one time in the roster form, not repeated, generally not repeated. If you want, you can write like this also. Suppose you have a set 2, 3. You can write also 2, 2, 3, or you can write 2, 2, 2, 2, 3, 3. But we don't repeat this because ultimately cardinality is same here. What is the cardinality? Cardinality is the number of distinct elements in a set. Number of distinct elements in a set is called the cardinality. So what is the cardinality of set A here? 2. In this case, there are only 2 distinct elements, 2 and 3. So cardinality is 2. This is not distinct. These are repeated. So only one time we will call 2 will be counted as one time and 3 will be also counted as one time. So cardinality will be 2 only. So that's why we did not generally repeat the elements in the roster form. Such that, or you can write right here, all the elements are taken as distinct. Next form is set builder form. In the set builder form, we take elements which satisfy a certain property. So what is the definition? All the elements of a set, this is very important definition, possesses a single common property which is not possessed by any element outside the set. Means the elements in this set possesses a single common property. If any element is not belong to that set, that means that element will not perform that property. For example, if we take any set A, a set of vowels, suppose A, E, I, O, U. So except these elements, no element is vowel. No element is vowel, or you can write down no other alphabet possesses this property, because all the elements possesses a common property. What is the common property here? All the elements of this set or alphabet are vowels only. So if we want to write the set builder form, so how to write the set builder form for this set? This is the roster form. This is the roster form, RF, and we want set builder form, SBF. So we take in the form of variable x. X is any element. X is the representation for x is a common representation for all these elements. Means now we have to represent all these elements by a single variable x. By a single variable x. Suppose you are in your family, like for my example, I am Anurag Shukla, my daughter is Anika Shukla, my father is some Mr. Shukla. So if you see the surname is Shukla. So X is Shukla here, because we have a common property here, surname. Surname is common property here. So we have to represent by Shukla family. So that will be the X element here. Now what is X here? X is a vowel in English alphabet. Now you can see that no other element perform this property. So this is in the set builder form. This is a set builder form. Now suppose you have another example, B. 4, 5, 6, 7, 8, 9. And these are the natural numbers. You can see that 4, 5, 6, 7, 8, 9. If we want to write the set builder form for this set, this will be X. X is a natural number. Okay. But natural number are starting from 1 to infinity. But we have to bound them. It is between 3 to 10. Between 3 to 10. No other element is performing, or no other element in this outside to this set is a natural number which lie in set B. So that will be 4, 5, 6, 7, 8, 9. It can have another representation also, or you can write this as SBF. We can write here also. If you are interested, you can write X is a natural number and has property 4 less than X less than equal to 9. You can use this definition also. But no other element outside this domain belongs to this set. So this is a very important definition that is called set builder form. Okay, I'm giving you one more example. If you see change in roster form. I have a set builder form. Set is, C set is, suppose X such that X is a element. This is the collection of element. And what is the property of that family of elements? Is a positive integer and X square lesser than 40. So what will be the set builder? What will be the roster form here? It should be separated by comma. Can you tell me? 1 square is also less than 40, 2 square is also less than, 3 square is also less than, 4 square, 5 square, 6 square, 7 square is greater than 40. And we can see that minus 2 square is also less than 40, but we are interested in positive integer only. So a collection of all X which satisfy this property, that will be the roster form here. Another example, if you see, change in set builder form. Suppose we have a roster form as 1, 4, 9, 16, 25. So can you see the property of the set here? Yes, this is the square of 1, 2, 3, 4, 5. So we can write set builder form as collection of all X. X is the square of natural number and 1 less than x less than equal to 5. So we have to take only the natural number which lie between 1 to 5, and we have to collect the square of that natural number. That will give you a roster form. We can see one more example. Suppose you have roster form as 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, and 6 by 7. Suppose this is a roster form. It is separated by comma only. Now you have to change in set builder form. So set builder form will be the collection of all x. And x is in the form of, you can see that denominator is 1 greater to numerator. If you have 1, then denominator is 2. If you 2, you have 3. You have 3, you have 4. More means it can be represented as n upon n plus 1. Now, what will be the condition on n? What will be the condition on n here? N is a natural number. And the condition on n is n will be lie between 1 to 6. If you put n equal to 1, you will get first fraction 1 by 2. If you n equal to 2, then 2 by 3. If you put n equal to 6, it will give you 6 by 7. Let's see the types of sets. What are the classification of set here? First is empty set. First is empty set. A set which does not contain any element is called the empty set. The empty set or null set or void set. There are 3 names. Its representation is very interesting here. We generally represent it by 5 or only curly braces. We don't write this is like this. This is not the correct representation of empty set. It is a representing a element, and phi is the element of a set. So it will be a singleton set. Only 2 representation for empty set, phi and a. If we see some examples based on this, first is collection of all x square minus 2 equal to 0, and x is a rational number. So if you see that the solution of this equation is x square minus 2 equal to 0, x equal to plus minus root 2, and this is not a rational number, it is an irrational number. So the set will give you ultimately a solution will be the null set, because we have no x for which this equation is giving you 0 or RHS. So the solution will be null set. Similarly, you can write another example. Collection of all x 1 less than x less than 2, x is a natural number. So between 1 to 2, there is a no natural number. So ultimately, you will get a null set that will be the phi only. We have another name that is called, another set that is called singleton set. The set which has only one element, has only one element. Or you can write like this. This is a singleton set. If you see the example, collection of all x, x is an even prime natural number. So can you tell me what will be the output for it? The number which is even and which is prime also, that is only element in this universe is 2, and natural also, it means this is the only element 2, so it is a singleton set. Next is finite and infinite sets. Finite and infinite sets. a set which is empty. Look at the definition. Empty set is also a finite set, or this is very important word, consists of a definite number of elements is called finite set, otherwise infinite set. For example, W be the set of days of a week. So you know that this is number is finite because there are 7 days in a week. Now second is, this is a finite set. Let G be the set of points on a straight line. So our points on a straight line is not countable because there are infinitely many points. So this set is a infinite set. Important is, infinite sets cannot be represented in roster form. This is very important word. Infinite set cannot be represented in the roster form, but finite set can be represented in roster and set builder both. Infinite set only representation is set builder. Now let's see another type, which is called equal sets. Two sets A and B are said to be equal if they have exactly the same elements and we write A equal to B. Otherwise, sets are said to be unequal, A not equal to B. For example 1, if we take a set A 1, 2, 3 and we take B is equal to 2, 2, 1, 3, 3, we can see that the elements in the set A is same as the elements in set B, so A is equal to B because both have same elements. And if you see the C set, which is in the set builder form, X is natural number and 1 less than X less than equal to, so 3, between 1 to 3. So you will get only this type of elements. So you can see that A equal to B equal to C. Next definition is subset. Subset. A set A is said to be a subset of a set B if every element of A is also an element of B. In other words, if we want to say here, A is subset of B. This is the representation for subset. This is not, sorry, A is subset of B. This is the representation. This is the representation. If whenever A is subset of B, if whenever any element belongs to A implies that A also belongs to B. Every element in set A also belongs to belongs to set B. If A is not subset of B, we write this representation. One remark is important here. If A is subset of B and B is also subset of A, then it will give you A is equal to B. It means the all element of A belongs to B and all the elements of B belongs to A. It means both the set have same element. It will become equal sets. One important point is more here. Every set is subset of itself only. And phi is subset of every set. Phi is subset of every set. Now let's see what is proper subset. Proper subset. Proper subset. Let A and B be the two sets if A is subset of B and A not equal to B, then A is said to be proper subset of B. B is called superset of A. Another word here, superset of A. It means all the elements of A belongs to B, but B have some additional elements also that is not belonging to A. Next is subset of real numbers. If we see on the real line, natural number is subset of integers. Integers is the subset of rational numbers. Rational number are the subset of real number. Rational number is subset of real number. One important point here, if we take here subset of irrational number, then it will be very interesting. Set of irrational number. So how we defined it? Irrational number is an infinite set. So we cannot represent in the roster form. So only the form is set builder. Suppose this is the T set of irrational number. So a collection of all x and a x belonging to real number, but x is not rational number. Real number, x is a real number, but x is not rational number. That will be the set of irrational number. And irrational number is also subset of real number. But if you see, this is your real number, rational number, and this is your irrational number, then the intersection of rational and irrational is a null set. What is the intersection? We will study this notation in the another lecture. Now let's see one more definition, that is called power set. Before power set, I am going to discuss here equivalent set. The sets which have same cardinality. Cardinality, I told you the number of elements in a set is called cardinality, are called equivalent set. Suppose A is a set with elements 1, 2, 3, and B have element A, B, C. A is not equal to B because the nature of the element is not same. The nature of the elements is not same. Here the elements of set A is 1, 2, 3, but the elements in set B are A, B, C. But if you see the cardinality, number of elements in set A is 3 and number of elements in B is also 3. So A is equivalent to B. This is the notation for equivalent here. Next definition I am going to write here, that is power set. The collection means set. We have to make a set. For making a set, we have to supply a curly bracket of all subsets of a set A is called power set of set A. It is represented as power set of A. If the number of elements in a set A is m, then the number of subsets will be 2 to the power m. And what will be the proper subsets? We cannot take one here, set itself, then will be 2 to the power m minus 1. Suppose you have a set A with the element 1, 2. What will be the subsets of A? It will be null set is always subset. We take one single element, then 2, then 1 comma 2. So these are the subsets. If you have 2 elements, the number of subset will be 2 to the power 2 means 4. It means what will be the power set of A? We have to just collect them. For collecting them, we have to use the curly bracket. So this is the power set of A. Now the question is how it comes 2 to the power m. So let's see, we have another result for that. How the subsets are 2 to the power m. If a set A has m elements, A1, A2, Am means cardinality of the set A is m, then the number of subset is 2 to the power m. I am claiming here. What is the proof? First, out of m, I am not taking any element, means MC not. I am not selecting any element. That will give you 5. Plus, I am selecting one element, one element. We can take A1 or A2 or A3 or Am. Why I am adding? Because when you are taking, okay, let's discuss later. If you take the collection of 2, then it will be MC2. If you take collection 3, then you MC3. And in the last, you can take all the elements. Now the problem is why I am adding here. Why we cannot multiply? Because when you are taking one element, pair of one element, you are not taking the pair of 3 element. Means events are mutually exclusive. Means if you are taking the collection of 2 elements, you are not taking the collection of 3 elements in the same time. So the selection is mutually exclusive. So we have to add. And you know that in the binomial theory, MC0 plus MCN plus MC2 up to MCM is equal to 2 to the power m, because it can be obtained from 1 plus x to the power m is MC0 plus MC1x plus MC2x square plus MCM x to the power m. If you put m x equal to 1 both the sides, you will get the same result. So this is the proof of number of subset. Now my doubt is why number of proper subset is 2 to the power m minus 1. Number of proper subsets. Suppose A is any set with the elements 1, 2. Then the subsets are 1, 5, 1, 2. 1, 2 we cannot take. This is not the proper subset because it is set only, itself only. So it is 2 square minus 1. We are excluding set itself. If you take the 3 elements, A, B, C, then 5, A, B, C, collection 2, 2, A, B, A, C, B, C, there are 7. We cannot take A, B, C because it will become set itself. So it will be 2 cube minus 1, 2 to the power m minus 1. Why minus 1? Because we are excluding the set itself in the proper subsets. So this is the number of proper subsets. Next is universal set, or we call it as basic set. So more on universal set and basic set, intersection, union, subtraction, we will see in the next lecture. That will be based on the algebra of sets. Okay, thank you.